right, homework handouts out, and if you would go and hold them up so that I can see that they are completed. Should look something like this, but filled in. And then on the back side, should have your limited domains and limited ranges of your trig ratios. Good. Let's go and take a look at these together, finding the inverse equation for each given function. Letter A, we were given f of x is 3x negative 4, and if we want to find the inverse, kind of walk me through the process here, Quentin.
Change the f of x to y, and then swap the x and the y, so x equals 3 and 4, then solve for y, so move the 4 over as it closes, and divide by 3.
And there we go. Y equals x plus 4 over 3. Will there be any asymptotes in this graph class?
No.
No, because the denominator will never equal 0. It will always simply be a 3. The next one, we had f of x is equal to x squared positive 3. Now, this is not a one-to-one function. So when we take the inverse equation, it will not be a function. Ethan, what do we need to do?
We need to change the f of x and y. Switch the x and the y. Minus 3. Square both sides. Or square root.
And here's why it's not a function. It's my idea to take that square root. Class, positive, negative. And right there, you plug in 1x, you're going to get two answers, one positive, one negative out of it, which means this is not a function, although the original was, but this is your inverse equation. How many have that for letter B? Forgot the positive, negative. All right, questions?
Does it matter, like at the end, do we have to have y equals that, or should we replace the y with the f of x equals
I
that?
wouldn't. Now here you could go inverse function of x equals x plus 4 over 3 if you wanted to. Here you can't because it's not a function. It's an inverse equation, but it's not an inverse function because you get out two answers. Here it really is an inverse function. I just leave the y. Because otherwise you have to think through, wait, is this or is this not a function? That's a pain. We don't want to think of that. We're too lazy. Looking at the next one, f of x equals 2 over x plus 5. And here we will have an asymptote, Jamie, in our graph. X cannot equal 0. All right, just a little side note for our graph if we were to construct one. By the way, how would I tell from a graph that it's a function or not, class? Vertical line test. You pass a vertical line over this, it never crosses more than once, it's a function. How did I know, if I'm picturing a graph, that the inverse wasn't going to be a function? Horizontal line test crosses too many times, where here you've got your line, vertical line test passes and horizontal line test passes. So this function is a one-to-one function because both it and its inverse are functions. Here, let's see. Getting something like that for our graph. So it's a function and the inverse will be a function as well. Again, you're not generally going to have to graph these, but again, vertical line test passes, horizontal line test would pass also. Jamie, what do we do to get the inverse?
You change f of x to y, then you'll switch the y and the x, and then you'll minus 5 on both sides. Then you'll divide by 2. So
what I'm solving for is in a denominator.
Alternate.
Alternate. Again, if you want to put the x minus 5 over 1, you can. That's going to give us y equals 2 over the x minus 5. By the way, here x can't be what, class?
Negative 5.
Well,
positive 5, right?
I said negative.
Okay, so x can't be a 5, which means in the original, y can't be 5. And so there's your asymptote at 5, and there's your asymptote at 0. So that's one way to find your asymptotes for the original graph. Obviously, those would switch. For the inverse function, if we were to graph it, and we looked at this yesterday, y can't be 0, and x can't be 5. And so we get a function that looks something like that for our inverse. Looking at letter D, we had f of x is equal to the square root of 3x plus 2. And back to Quentin, what do we do?
Change the f of x to y. Square both sides, or change.
You're right. Oh, sorry, no, you're not right.
Switch the x and
You're
y.
right.
You're one step ahead of yourself. No, you were correct to catch yourself. Switch the x and y, then square both sides to get x squared equals a 3y plus 2.
Move the 2 over as a negative and divide by 30.
And there we go. There's our inverse. How many have this four-letter D? That is a function, by the way. Plug in 1, get out 1. All right, letter E. Ethan, we have f of x equals 7 over x plus 4. By the way, what can x not equal, Ethan?
-4.
-4, so we're going to have an asymptote there. Of course, we're going to replace the f of x with a y, then what?
Towards xy.
To get x equals 7 over y plus 4, then?
Alternate.
Good. What we're solving for is in a denominator. We're going to have to alternate the y plus 4, and then the x down in the bottom, and then finally...
You put the y plus 4 over 1.
Well, the x was over 1, so that's why I alternated. But I'm just trying to get the y by itself. It's easy. One step to get y by itself. Just get rid of the 4.
-4.
-4 on the other side. And there's our inverse equation. By the way, what can x not equal now, class? 0. So in the original function, y can't equal 0, right? Because if x can't be 0 now, then y in the original couldn't be 0. And there we go. Questions on A through E. All right, clear your desks, except for a clean sheet of paper, pencil, and a calculator. We'll get back to those limited domains and ranges and stuff, but that's not going to be on this quiz, just practicing with functions, inverse functions, that sort of thing.
Can you go over one more alternate thing real quick? I have a problem with alternate.
If it's in the bottom, you've got to alternate it out. If the y, because you're always solving for y, right? If you're solving for the y, it's in the bottom, alternate that bottom, the whole thing, whatever it is, maybe it's a binomial, with whatever's on the other side, because whatever's on the other side is over 1. So even if it were something ghastly like 3x negative 7 equals 5 over 7y minus 2, we're going to alternate the entire 7y minus 2 with the entire 3x minus 7. All right. First last name at the top of your paper, along with today's date. First and last name at the top of your paper, along with today's date, which is 12/7/21, the 80th anniversary of the Pearl Harbor attack. So Pearl Harbor Day today.
80th?
80th, 80 years ago today. 80 years ago, well, no, it is about, let's see, in Hawaii, that's 5 hours later. Not quite 80 years ago. In a couple hours, it'll be 80 years ago. But if you haven't seen a documentary on the Pearl Harbor attack, I read a book this past summer. I was spending a lot of time reading, so I read a book, Day of Infamy. It's in our library, and a really good documentary of all that went into the Pearl Harbor attack from both sides. You get to see the Japanese perspective as well. And anyway, that's neither here nor there. Pre-cal quiz. This is quiz 23. Quiz 23. Let's take a look at the quiz together, and then we'll let you get started. The first 8 questions, you are either going to write yes, or you are going to write no. Okay, you are either going to write yes, or you are going to write no.
Or maybe.
No, it's either yes or no. I do want to point out on that last graph, there's a part where it looks like a line is horizontal. It is not. The line never goes perfectly horizontal. I just want to make that clear because I've had students be confused in the past. So don't overthink that last graph. Numbers 9 through 13, or number 9 through 11, excuse me, you are going to be finding inverse equations. Number 12 refers back to the given equation in number 10. Number 13, just ask a question. And then there's a bonus for you as well. Yes, ma'am.
So it's 1 through 8 is yes or no?
1 through 8, the only answer you're writing is either the word yes or the word no. All right, you may begin. Be sure to use that quiz copy as a cover sheet. Sure you keep your answers covered as you work. A couple more minutes to be finishing up. If you need a little bit more time, take about 1 more minute to work on your quiz. But those students in here are finished, so we're going to proceed. You can go ahead and pause the video if you need a little more time. All right, go ahead if you would please and take out your notes. And yesterday you copied down limited ranges and domains. Key to remember as we look at inverse trig ratios is that what was x has become y, and what was y has become x, right? So what was domain before, class, becomes range. And what was range before becomes domain, except it can't, because then you don't have an actual function. So what do we do to make it a function? Well, we limit those ranges. So let's go ahead and see what we can remember here. Try to do this without looking back, but to have the notes handy in case you get stuck. We have 6 trig ratios, trig functions. Again, the inverses on their own are not functions. We artificially make these functions. And again, as we think of the domain, we need to picture what was the old range. So for sine, picture the graph. What did it do vertically, class?
-1 to 1.
-1 to 1. So that becomes the domain of the arcsine. Make sense? What did cosine do vertically? Same thing, negative 1 to 1, right? What did tangent do vertically? Limitless, right? So that's what tangent's going to do horizontally now. What about cotangent? Same thing. What did secant do vertically before?
It was limited all the way up to -1.
And then from 1 up to infinity, right? It was negative infinity up to the negative 1, then 1 to infinity. So that's what it's going to do horizontally now. Negative infinity, negative 1, and then positive 1 to infinity. What about cosecant? Same thing. And again, so you remember these in pairs, but also remember them based on the graphs. We spent all that time graphing them. Remember, what did the graph look like? That's what the domain is going to do now. The old vertical becomes the new horizontal, but the ranges have to be limited. And the ranges are either going to be limited to include quadrant 1 and quadrant 2, or quadrant 4 and quadrant 1, but we use negatives in the quadrant 4. So here's a good way to think of this. Sine in quadrant 1 and 2 is positive in both. That would give me 2 answers. So sine, we're going to use quadrant 4 and quadrant 1. How could I describe quadrant 4 and quadrant 1?
Negative 90, 90.
Negative 90 to 90. Does that make sense? Whereas cosine in quadrant 4 and quadrant 1 is both positive. You can't do that, right? So we're going to go with quadrants 1 and 2, which would be described as being class 0 to 180. Or 0 to pi, right, if you wanted to use the radians. Tangent could go either way, right? It could either be 1 and 2, positive, negative, or 4 and 1. But because of that asymptote at pi over 2, we decided to make tangent follow the sine.
Negative 90, 90.
But there's asymptotes at the 90 and negative 90. So negative 90 to 90 with parentheses. Again, picture the graph of the tangent. Remember, started at 0, whoop, to an asymptote. And if we go backwards, it's whoop, to an asymptote. So that's why we're going to put parentheses at the ends. Cotangent, to avoid the middle asymptote, we're going to make it match cosine.
0 and 80.
But again, there's an asymptote at 0 where the cotangent started, and an asymptote at 180 where it goes whoop. So in parentheses, 0 to 180. That makes sense? Again, we're picturing what did the old horizontal do. That's our new vertical. All right? Then secant was obviously, it just goes right hand in hand with cosine, doesn't it? So,
0 to 180.
but for secant, the asymptote's in the middle. So we're going to say with brackets 0 to 180. And how do we leave out the middle? We just say
Except,
Except at 90.
except at 90 degrees. There's no value there. And then cosecant is going to match up with sine.
Negative 90, 90.
But remember, there's that asymptote in the middle of our last two, secant and cosecant. So let's say except.
At 0.
Does that make sense? All right. Obviously, we see that on the board as well. I'm going to go ahead and show the bulletin board there. We've got our guy who is trying to lift not even that much. High top of Ethan's head, but trying to lift weights and needs to know his limits, right? Don't want to get in the weight room, especially on the bench press, right? Because if you can manage to just get it off the rack and then it goes down and doesn't come back up, it's a bad day. Have you seen those videos on YouTube and stuff? This guy tries to lift weights, and what is the first? He's working out in his garage or whatever, and he always screams for mom. I'm like, dude, if your mom can lift this, Mom, can you spot me? Anyway, we got some work to do, both. But anyway, we see those limited ranges there for our inverse functions. All right, coming back over here now to the board. Let me show you how we're going to use these over the next week or so as we work with this. You're not going to have to do this yet. Where did I put my chalk down? On the desk back here. Chris, stop laughing. I heard that. All right, let's go and take a look at this. So what we had done in the past, right, is we'd say tangent squared theta minus 2 equals 1. And so if we wanted to solve the trig equation class, we'd start by adding the, and then we take the, to get that the tangent of theta equals over 1 positive negative. There we go. And then we'd ask ourselves, okay, when is tangent square root of 3 over 1? Well, really what we were doing was we were taking the arc tangent. In fact, sometimes we had to do that on our calculator, didn't we? Not very often, but every now and then. And so we found that the reference angle for the square root of 3, opposite over adjacent, 60. And we said positive, negative, all 4 60-degree angles. 60, 120, 240, 300, right? But tangent as a function can only spit out values between negative 90 and 90. Now, as an equation, this is true. In fact, we could just keep adding 360 all day. There's an infinite number of angles that this would work. But when your calculator does things, your calculator is a functional instrument. It only knows how to spit out one value. So this limited range really shows what your calculator does. If you take the arctangent of the square root of 3 on the calculator, it doesn't give you 60 and 240. It only gives you 60. And if you take the arctangent of negative square root of 3, what does it give you?
Negative 60.
Negative 60. It gives you this quadrant 4 angle, again, quadrant 4 and quadrant 1, but it gives you the coterminal negative angle. It can't give you any of these angles because it doesn't fall within the range that arctangent as a function has been limited to. Again, your calculator can't spit out multiple answers. It only knows how to do one answer for one thing. So as we work with these, we're going to kind of approach the same thing again, but we're going to look at, okay, what about from a functional perspective? What is the calculator going to do? That's all the calculator will do. Does that make sense? So for instance, if we said 2 cosine theta minus 1 is equal to 0. All right, what would we have to do here, class?
Move over 1 divided by 2.
To get the cosine of theta equals
1/2.
1/2. Now again, without using the calculator, we know we would take the arc cosine of 1/2 and just say, okay, well, when is cosine? 1 over 2, adjacent over hypotenuse.
60.
At 60. And we would have said before, okay, when is cosine positive? Well, in quadrant 1 and quadrant 4. So we'd have said 60 and 300. But again, arc cosine is limited as a function to 0 and 180. So one of those angles doesn't fall between 0 and 180. 300's out. Your calculator, if you were to take the arc cosine of 1/2, will only give you 60, not 300. So what we looked at before was equations. Now we're going to look at, okay, what about with functions? This slight difference. Does that make sense? That's what's coming. Also, if we had something like this, the sine of theta minus 2 is equal to 1. Well, of course, here we'd have to move over the 2 to get the sine of theta is equal to 3. Of course, we would take the arc sine of the 3 to get theta, but, well, can you take the arc sine of 3? No, because remember, arc sine's domain is between negative 1 and 1. That falls outside the domain, so you can't even take the arc sine of that. Your calculator might say syntax error, it might say domain error, or just says error, math error. Here your calculator reacts because that's not in there. That's not within the domain. This has no solution. We kind of looked at that before, but we hadn't looked at it from a specified perspective where domains and ranges were memorized. So that's where we're headed. And so it's imperative that we know these, especially the limited ranges. Because the limited ranges for each of these functions is going to tell us, okay, I can only keep these answers, I can't keep those answers. Oftentimes I can only keep this one value, and we'll go from there. But that's what's coming. In the meantime, we just need to memorize. For now, let's go to our next section of notes, which is finding inverse trig equations. Finding inverse trig equations. Again, not the inverse trig functions yet. We still need a little more practice. A little more time, I should say, to memorize the limited domains and ranges, but we can find inverse trig equations. And it's really going to be the same exact thing we've pretty much been doing this whole time. Write this example problem down. Y equals 3 times the sine of 2x. Now, if we were to graph this, we know the amplitude is 3. We know my key points are 0, 1, 0, negative 1, 0. We know the period is 2 pi over 2 or pi. So we're going to go 0, 3, 0, negative 3, 0. We'd squish it all between 0 and pi if we were graphing it. Y'all are relieved we're not going to graph it, okay? But obviously, if we do the inverse, the whole thing would rotate and flip. Again, we're not graphing any of that. But what we do want to do is, what would the equation be for the rotated, flipped, inverse equation? Well, step number 1 is to switch x and y. Probably saw that coming. So instead now it's going to say x, doing this with me, equals 3 times the sine of 2y. That's what we always do for inverse. That's what makes it inverse, is that x and y are now switched. And then we get y by itself. Well, remember I said when we're getting a letter by itself, we always get rid of the least attached thing first.
3.
The 3 is the least attached. How do I get rid of the 3? Divide it to get x thirds equals the sine of 2y. Now what's the least attached thing?
2.
No,
Sine.
the sine. How do I get rid of sine? You take the arc sine of both sides, right? The inverse of multiplication is division. The inverse of sine is inverse sine or arc sine. So that's going to give me the arc sine of x thirds equals 2y. Make sense? Now the last thing we have to do is get rid of the 2. How do I get rid of the 2? Divide it. However, I will say this. This just looks gnarly, right? This looks ghastly because we have a fraction over in a fraction. It's complex. So my recommendation is instead of dividing by 2, multiply by the reciprocal. Make this a 1/2 times the sign. That way we don't have a fraction within the fraction. It's just a progression of fractions. And there's the inverse. Here's the original, and there's the inverse. And again, my strategy, my recommendation would be just so it looks better, if you already have a fraction, don't divide, multiply by the reciprocal. We'll just make it look nice and neat. Turn to your books, page 158. Turn your textbooks to page 150. Let's do a few of these together, then I'll let you work a couple of these on your own. Page 158. And at the top of the page, number 1, pretty easy one, y is equal to 2 times the sine of x. If we want the inverse equation, what's the first thing we got to do, class?
Switch the x and y.
Switch the x and y. Thank you, point. What's always the first thing we do to find an inverse, class?
Switch the x and y.
All right. Next thing we ought to do here, Jamie.
Do we go ahead and divide the 2 away?
Good. The 2 is less attached than the sine is, so let's get rid of the 2. Divide it away. X over 2 equals the sine of y. Then we will
Take this. What's called arc sine?
take the arc sine, or the inverse sine, of both sides. So here I show that I'm taking the inverse sine by crossing it out, and I'm done. Or I could put the y over here if I just wanted to look neater and say y equals the arc sine of x halves. Easy enough? So number 3, write this one down. Y equals 4 tangent squared 4x. Y equals 4 tangent squared 4x. What do I need to do to find an inverse equation here, Quentin?
Switch x and y. And divide away the first 4.
Good. Divide away this 4 to get x fourths equals the tangent squared 4x. And be careful. Now what? Good. You can't get rid of the tangent because it's being squared. So I've got to take care of the square before I can take care of the tangent. Does that make sense? If I wanted to think of tangent squared 4x as being the tangent of 4x squared, now we can see the squared is less attached because it's not within the group, right? But we don't generally write it that way because mathematicians are lazy. But we have to get rid of the squared before we can get rid of the tangent. So we'll take the square root of both sides. Obviously here that just gives me the tangent of 4x. Over here, when we take the square root, remember you can't have a denominator. So we have to take the square root of 4.
2.
But we can't really take the square root of x, but we don't care because it's a numerator.
So square root of x, positive negative.
But good, it's our idea to take the square root, so we're going to need a positive negative on there. Questions on what Quentin just did? All right, now what?
Get rid of the tangent.
By taking the...
Arc tangent.
And because this is so messy, I'd recommend putting it in parentheses. You see I kind of did that here as well. Okay, when it's messy, I like to have the parentheses around what we're taking the arc tangent of, but we're still not done.
Times 1/4.
Good. Divided by 4 usually, but if you do that, it looks like a complex fraction. So instead of divided by 4, times 1/4. And this is a y, by the way. You said switch the x and y, and I now have 2 x's. Chris has been streaming this at the computer screen this whole time. And I just finally heard him, so thank you, Chris. Questions on that? Ethan's like, I never get credit for anything when I'm gone. Sorry, he's favorite, you know?
Oh,
All right. Questions on this? Okay, Ethan, your chance to be favorite. Number 5. We got y equals 2, secant squared x over 2. What do we do here, Ethan?
Or change the x and y.
Good. Switch the x and y first. Let's make sure I do it correctly this time. 2 times SEC squared, which means 2 teams in the playoff. That's SEC squared. So I watched. There's two YouTube channels that I really like. I will endorse these on my YouTube channel apparently right now. But SEC Roll Call with Matt Mitchell is really funny, and then SEC Shorts. SEC Shorts has a lot more notoriety. Matt Mitchell's SEC Roll Call is a new thing. But anyway, both of them, I'm like, okay, what are they going to do to Georgia in these? And the one, they have this dance setting where all the bowl games are the beautiful women, and the guys are the universities going to these different bowl games. And Georgia, like the player's like, come on over, Georgia, let's dance. He's like, no, I don't want to. He sits there pouting, and then Hope comes to him. He's like, no, you gave it to the Braves, but you won't give it to me. No, so they're sitting there arguing the whole time while Alabama dances with the playoff. But technically, Georgia's date was the playoff also, but he's busy arguing with Hope because he refuses to have hope. I will not have hope. But anyway, Alabama crushed. And then in Matt Mitchell's SEC Roll Call, Alabama's laughing, and then Georgia's over there in the corner, like laying there on the floor, scared and trembling and whatnot. So anyway, sorry. Notre Dame didn't even get a mention, and we usually get a mention because we're usually in the playoff, but not this year. So we didn't even get a mention, but usually they smash Notre Dame in them too because they like to smash Notre Dame just like all the playoff teams do. All right, Alabama, Clemson, really those two, Anyway, coming back over here. We got off on the SEC squared thing there. That was not good. All right, Ethan, we switched the X and Y. That's as far as we got, which is like switching first and third in the poll. So what do we need? Poor Chris. I'm having way too much fun at his expense.
Alabama.
We stayed at we moved up to number 5. That's not much. Anyway.
It's not much now.
At least we're not.
Divide
Divide the 2 away. And so X halves equals SEC squared of Y. Secant squared Y over 2. Then what?
Square both sides.
Oh, Ethan. Alabama fan was rejoicing and gloating too much, and he just committed a false start.
Oh, really?
We don't square both sides. Square root of both sides. There we go. And that's going to cancel this, but be careful. Just like before, we have to take the root of the bottom. Well, Quentin had it easy, right? Square root of 4, that's 2. But you have to take the square root of 2. Right? So it's like Georgia, your path to the championship is now harder. Okay, so you've got to
Can we stop?
eventually, when I run out of jokes. But math just lends itself to jokes about football. What can I say?
It really does.
It really does. Well, if you wanted to. Anyway, all right, so I can't take the square root of 2. I got to make it work. It's like Stenson Bennett, we're just going to have to make this work.
Throw 2 interceptions.
2 interceptions, good. Multiply top and bottom by a 2. So that is the square root of 2. X over 4. Good job. See, I knew if we just kept talking math or football, you'd eventually come to the right math answer. And
square root of 2.
Chris has turned it off. We might as well stop. All right, so
square root of 2x over 2.
Good, the square root of 2x over 2, but good, positive, negative. Those little details that are the difference between winning and losing a football game. And you paid attention to it, Alabama fan. And then, see, I hate Alabama. I don't even hate Georgia that bad, but I really hate Alabama. I don't know why I'm ripping Georgia. I was doing it in choir practice, too. My next door neighbor is a Bama fan, and then our pastor's wife sitting next to each other, she's a Georgia fan. I kept giving her a hard time. Like, I was cheering for her team. Why am I making fun of her? I can't help it.
What were you saying to her?
I don't even remember, just random stuff that I won't remember later. All right, all equals to secant of y halves. All right, now what do? We get rid of the SEC. That's what the Big 10 and Big 12 want to do too.
No, Texas and Oklahoma wanted to on the SEC.
They thought they did. They've now decided this is a horrible idea, but they're stuck now. So
they are?
I don't think they can back out. The contract's already been signed, so they're coming, and they're never going to be relevant again.
No, they're not going to be good again.
They have high hopes of good recruiting. Good luck with that. Kind of like Brian Kelly and his fake accent. Oh yeah, they definitely got Brian Kelly and his fake accent in those videos too, and I thought that was well played. All right, anyway, but we got to get rid of the SEC. So what do you do, Ethan?
Arcs. Secret.
Arcsecant. And again, my recommendation, put this lump of junk all in parentheses. And then the final thing to get the y by itself.
Multiply by reciprocal.
Which is,
2 over y.
well, but that would get rid of the y. So let's not multiply by the reciprocal of the whole y over 2. How about just multiply by 2 over 1? Or just multiply by 2. And that would get y equal to this. So you didn't quite finish it out as favorite student. And evidently, as much as we're picking on Chris, evidently he's still favorite student. But there we go. Questions on this? All right, do 7 and 9. Catch your seats. 7 and 9.
Wouldn't say anything else.
No, we probably ought to stop because we only have like 2 or 3 minutes left. And
Oh, yeah.
that's what I get for reading poetry to my class before starting the video. It's very educational,
Yay.
Christopher.
You like what?
We have Walt Whitman, William Shakespeare, and Henry Wadsworth Longfellow. Is he the village blacksmith? I think? Longfellow? Yeah. So I mean, all the greats got their shout out before class today. And just to say, I destroyed their work.
Oof.
Kind of like Alabama did to Georgia.
41 points against a team that I won about 6. At 6.5.
A game, yeah. I think they had a lot of 48 points or something like that the entire season, something like that.
Yeah. And we scored 41.
Well, to be fair, 6 of those points came off a defensive, scoop and score. Still, so that wasn't against their defense, but that's still 30-something points against the defense.
Yeah, not 6. 7 and 9.
Yeah. It's a great day to be an LSU Tiger. I'm here with my family, and we're just so excited to be here in the great state of Louisiana.
So
That
bad.
sounds like a real accent.
They're so bad. They're about to lose.
Oh, why can't we just go talk like this? I couldn't understand everything said, but no, sound real cool.
You can hardly understand everything.
All right, Quentin's done, Jamie's done, Ethan's still laughing at Chris, so it's hard for him to get done. So we switch the x and y. We divide away the 2. Take the arc cotangent, multiply by a 4th, and we're done. How do we do on the first one?
Good.
On the next one, we multiply switch the x and y.
Oh my
Multiply the
goodness.
9. Take the square root, which is going to give me positive negative 3 times the square root of x. Take the arctangent of that. We can, because this doesn't have a fraction, we can just divide the 4 or multiply by the 4th, all equal to 1. Questions on that one?
Easy.
All right, your homework this evening is to do 5 of these easy problems. Page 158, 2 through 10 to even. Page 158, 2 through 10 to even. And the reason it's so short, work on memorizing your limited ranges, because if you don't have them memorized, tomorrow's going to be a really challenging lesson for you. Make sure you've got them memorized. I didn't say that. Make sure you've got your limited domains and limited ranges memorized. But in addition, page 158, 2 through 10 even. Have a wonderful rest of your day, and you are dismissed.